All right. So the first one here says determine whether the graph is a function or not. So when you have a graph, you can do the vertical line test. So if I can draw a straight line through and touch the graph more than once, then it's not a function. It says then find the domain and range. And if you remember, domain is your left and right side boundaries, okay? So on the left side of my graph, all right, on the left side for your x, it's less than or equal to 6. And then on the right side, you'll notice that we have the arrows, so it's going to infinity. There's not a boundary, so my domain is just going to be everything less than or equal to 6. For my range, you're looking at the top and the bottom of the graph. And again, you have your arrows, so it's going to keep going on down, and it's going to keep going on up. So for your top and bottom, there's not a top and bottom because it's infinite, so your range is going to be all real numbers. Okay? So all real numbers for your range, and x is less than 6 for your domain. All right. All right, the next one, it says approximate when the function is positive, negative, increasing, or decreasing. All right, so our positive is every part of your graph above the y-axis. Above the x-axis, sorry. So those would be in the positive part of the graph. So that's in between 1 and negative 1. So we're going to say x is less than or equal to 1, but greater than or equal to negative 1. For my negative part, it's down here. You got two separate sections. So we're going to say for this, it's when this is x is negative 1, so when everything less than negative 1, and over here, it's everything greater than positive 1, sorry. Okay, so it's going to be, and this is just going to be, you don't have to do the r equal to. All right, okay.
You have a call on Park.
All right, the next part is asking us when is it increasing, okay? So we're not looking at the positive side or negative side. We're looking at when the graph is increasing. So this section here, from here to here, where our value, x value is increasing, right?
Yes, Lisa Simmons.
All right, so this goes to infinity, right? So when x is less than 0, it's increasing, and then over on the other side where it's decreasing, it's always decreasing when x is greater than or equal to 0. Okay? And you're looking at your x, remember your x coordinates, okay? All right. Let's look at this one. It says, does the equation represent a linear or nonlinear function? So how do we distinguish if it's linear? And if you remember, we said that it can be written
Put it back on park.
in y equals mx plus b. So if I can write a function in slope-intercept form where your exponent for x is 1, you don't have any exponents greater than 1, your y, you can get it by itself, okay? So looking at this equation, can I put it in slope-intercept form? Well, yeah. This x plus 3, what is it doing with the y? It's dividing. So if I multiply by x plus 3, it'll cancel out and leave me with y. But I also want to do the same thing on the other side, right? So simplified, we would get 4x plus 12. So, yes, it does. Okay. All right. The function y equals 60 minus 8x represents the amount of money in dollars that you have after buying X number of movies. Okay? So y is the money you have, and X is the number of movies you buy. Okay? All right, so identify the domain in the range of the, or identify the domain of the function. All right, so if we're buying, we're not going to have negative money, so I'm going to leave it in quadrant 1. And I like to put it here to kind of represent. So think about your x and y intercepts, because what's our dependent variable is the amount of money we have remaining, right? Because it's dependent on how many movies that I buy. And this is your dollars left over. So I started off, I had $60, right? And I haven't bought any movies. So I need to know, when is my Y 0? When am I out of money? Okay, so that would be my x-intercept. All right, so when am I out of money? So y represents the money remaining. So if I solve, I substitute y with 0, then I'm going to get negative 60 equals negative 8x. So negative, we're going to divide by negative 8. So that's going to be, it'll go in there 7.5 times. All right, so here's 7, here's 8. So it's going to hit 0 about right there. And we're starting out at 60. So my graph's going to look like that. Now, would it be continuous? Or would it be discrete? Continuous is if it's a straight line, right? But can I buy half a movie? No. So this is going to be discrete. Okay, our money's going to change every time we do a movie. So let's just, if I have 50, 40, 30, 20, 10, and 1, 2, 3, 4, 5, 6. All right. So if I have my little imaginary line there, if I buy one movie, I had 60. How much does a movie cost? $8. So I'm gonna have $52, right? And then if I buy another movie, 52 minus 8. All right, so that's gonna leave.
Miss Bryant.
Just a minute. It was 44. So about right here. And then for $8 more would be 36. $8 more would be 28. $8 more would be 20. $8 more would be 12. $8 more would be 4. And then we couldn't go $8 more would be 4 in the hole, right? So this would be discrete because I can't buy a half of a movie. Okay? All right, so what would my domain be? All right. Can I buy 8 videos? No, but I can buy 7, right? So it's going to be here because it's discrete. Okay. There's your graph a little bit cleaner there. Okay. All right. This says to evaluate this function f of x when x is -3, 0, and 5. So we're going to do first, what is it?
Brian.
Sorry. When x is -3, so we're replacing that x with -3. So it'd be -3 plus 8. So y would be 5. And if we substitute x with 0, if x is 0, then y is 8. And then if x is 5, 5 plus 8, y would be 13. Okay? Remember, this is the same thing as y, right?
Cafeteria.
So if I
Go ahead.
say,
I need Lily Bradley to check out, please.
if I gave you
Hey, Lily
that,
Bradley.
all right, so remember, if I give you that, I'm telling you it's the same thing as saying y is 2. All right, so if I had that function there, it would be 2 equals x plus 8. So -6 equals x. So when x is -6, y is 2. Okay, so just kind of a refresher on function notation. All right, let's look at the next one. So let P of t be the number of people in a stadium t hours after 11. Okay, so y is the number of people, t is the number of hours after 11. Explain the meaning of each. All right, so for A, it says that P3 equals P5. So what they're telling us that when you're doing this function, when t is 3, so it'd be 3 hours after 11. So the number of people in the stadium, so 3 hours after 11, so
Mr.
11
Huffman.
is 12, 1, 2.
Yes, ma'am.
Is Calhoun with you?
So
He is.
He can come.
at 2 p.m. is
He is
equal
on.
to the number of people in the stadium. At what time? 5 hours after 11. So at 4 p.m. Okay? All right, and then B, it said P of 6 is less than P of 230. So 6 hours after 11 would be 5. So the number of people
Administrators, has anyone seen Story, Ivy, or Kaylin
at
Coker? They did not report to class.
5 p.m. is less than
She saw
the
story
number
Ivy
of
just a minute
people
ago.
at what time? 2.5 after 11. So that would be 1:30 p.m. Okay. The next one says to graph this. So this is slope-intercept form, right? So my slope is the coefficient of x, so -2 or -2 over 1. And then my y-intercept is the number after your x, so take the sign with it, -3. So your first step is to graph the point -3 on your y-axis. So that's your y-intercept. So that's a point on the graph. Slope is a movement, it's not a point. But I can use that movement to find the other points. So if my slope is -2, I can go down 2 and then to the right 1. And I can keep doing that, down 2, the right 1. Or I can do the opposite. Because down 2 to the right 1 would be -2, right? If I did the opposite and went up 2 and to the left 1, it'd still be -2, okay? So if I go up 2 and the left 1, up 2, left 1, and if you notice I keep doing that, it's on that line, okay? So you only need really just do 3 points and you'll be good. But draw your line from, it's got the arrow from one end of the graph to the other. Go all the way across. All right. And this one says, again, graphing slope-intercept form, right? So my slope is 2/3, and my y-intercept is +4. So I go to +4, and then my slope is 2 over 3. Remember, on slope, the numerator gives your change in y, so it's up and down. Your denominator is your change in x, so it's left to right. So it tells you which way to go. So I'm going to go up 2, and then my denominator is +3, so I'm going to go to the right 3. And there's your line. Okay, look at the next one here. It says x equals 6. All right, this is one of those special lines. It's not crossed, there's not a y, so it's never going across y. So it tells you what to do. Cross x at 6. So I'm crossing, here's x at 6, and my line's going to cross it. So this is a vertical line. And the slope is undefined, okay? And every point on this graph, every ordered pair on this graph, like this ordered pair right here would be 6, 6. This ordered pair is 6, 2. This ordered pair is 6, -2, okay? If you notice, they all have their x coordinates at 6, so that's why it's a vertical line. Okay. So let's go to. All right, this time we don't have an X, so this is going to be a horizontal line.
Officer Marks, what's your location?
All right,
Outside the cafeteria.
and it says to cross the Y at 3/2. And 3/2 is the same thing as 1.5, isn't it? So we're going to go to 1.5 on your Y-axis and draw your line. And if you'll know, every point on this graph, like this ordered pair would be 4.5 with 1.5. This ordered pair is 0, 1.5. This ordered pair is -6, 1.5. Okay, so when you have a horizontal line, all of your y coordinates are the same. And your slope is 0. Okay. All right. This equation is in standard form. All right, which is ax plus by equals c. And when it's in standard form, we can get the x and y intercept. Okay? Slope-intercept form will only show you the y-intercept, but you can get your x-intercept easily from standard form. So to get my x-intercept is c divided by the coefficient of x. All right? So it's going to be 6 divided by 2. So my x-intercept is 30 right here. And then my y-intercept is c divided by b, the coefficient of y. So it's going to be 6 divided by 3. So my y-intercept's 2. So my x is 0, my y is... So that would be here. And then we can just connect the dots. Okay. All right, this one's wanting you to graph. You can do either way. You can do x and y intercepts, or we can convert it to slope-intercept form, which if we get the y, positive y by itself, it'd be 1/2 x plus 2. So you can graph either way. I can either do my y-intercept, go up 1 to the right 2, down 1 to the left 2, or I can get my x-intercept, which would be -2 divided by 1/2, which is the same thing as -2 times the reciprocal. So it'd be -4, which it is. And then my y-intercept would be -2 divided by -1, which is 2. So 0, 2, which it is. So, like I said, you can do that either way. Keep it in standard form or put it in slope-intercept form and graph it that way. Okay. All right. It says describe the slope of the line. Okay. It's from left to right. It's moving uphill, so it's positive. And if you need me to find the slope, I can pick a point that's on the line, up 1 to the right 2. Slope is 1/2. Okay. Okay. It says the points represented by the table lie on a line. What is the slope of the line? Well, remember, slope is your change in your y over your change in your x, right? So my change in my y, what is it doing each time? We're adding 6. Okay, so that's constant. Remember, a linear has to be constant. And then my change in my x's looks like we're adding 5 each time. So it's 5. So my slope is 6/5. Okay. Is there any others on this page? No. All right. It says graph the linear equation and identify the x-intercept. Okay. So my slope is 2, my y-intercept's 4. So there's my y-intercept, go up to the right one. And they want my x-intercept, so I can continue down, doing the opposite, down to left one. Oops, sorry, my pen's. To left one, down to the left one. So it's intercepting. My x-intercept is -2, 0. Another way you can find the y-intercept without, the x-intercept without graphing, if you notice at the x-intercept, your y-coordinate's always 0, right? So if I substitute 0 for y and then just solve for x, so -2 equals x, all right, which is what we have. So just a reminder there, you can plug in 0 or substitute 0 for y. All right, graph the function of x, 3x plus 4, and then the new function of f of x plus 3. So we're looking at transformation here, and they've already got the graphs. I've already got the graphs on there for you. But if you're looking at the transformation, so we start off with f of x, so we're going to make a new function, and it's going to be the same as the f of x, however, we're going to add 3 into the function. So this is inside opposite world. Okay, so anything inside that opposite world, inside those parentheses or absolute value bars, you're going to be doing the opposite. All right, and it's always, if it's anything happening inside there, then it's going to deal with horizontal. Anything on the outside deals with vertical. So we're dealing with horizontal. So we're doing +3. So any plus or minus is going to be a horizontal shift to the left or right. So if it's +3 here, when I take it out, it's going to be the opposite, -3. So we're going to have a horizontal shift to the left 3 units. Okay. So here's what this function is, this line. Your original function is that line. And then we just shift it 1, 2, 3 to the left, and we can make a dot there. And we can take this point and shift it 3 to the left, and then just do our graph. Okay. All right, our transformation here is we're adding 1, and it's on the outside, right? It's on the outside. So that means that it's a vertical shift, and it's +1. We don't have to do the opposite, okay, because we're outside of the opposite world. So it's a vertical shift up 1 unit. So here was my original line, f of x. So for my new line, h of x, All we did was go up 1 with our points, and then graph our line. Okay. Okay. All right, on this one, our change in our f of x, what did they do different? We've got that negative inside the parentheses. So if it's inside the function, it means that you're dealing horizontal. Okay? So we're dealing horizontal. And that negative means a reflection. Okay? So now, if I'm horizontal reflection, remember horizontal goes left and right, so it's going left and right, so it's crossing over the y-axis. Okay. If it was outside, if I had like negative fx, then that would be vertical reflection over the, and vertical would be going this way, so it's over the x-axis. And here's one right here. So it's on the outside, so it's vertical reflection so we started out here and we flipped over. All right, so it's reflection over the x-axis. Because if I did this, this would make my equation h of x would be negative 3x minus 4. So if you notice, my y-intercept went from plus to minus, and then my slope went from positive to negative. Okay. All right, on this one, what changed about our f of x is we're multiplying by a number, okay? So this is on the outside, so this is going to be either a stretch or a shrink. So if a is greater than 1, and when I say a, I mean like that. So 3 is greater than 1. So if it's greater than 1, it's a stretch. If a is less than 1 but greater than 0, so it's a fraction, then it's a shrink. All right, so this is on the outside. So outside always means you're dealing with vertical. So it's going to be, we don't have to do anything to the 3, so it's a stretch, vertical stretch by factor of 3. Okay. Vertical stretch by factor of 3. So on here, what you're doing is you're multiplying the whole thing by 3. So our new function would be 9x plus 12. Okay? So you can see that. Okay. It says to graph this absolute value plus 6. So this works the same way as we did for our linear transformations. It's on the outside, so it's a vertical shift up. All right, so remember, parent graph, your parent function for absolute value would be your origin, your vertex is at the origin, your slope is 1, positive 1, and negative 1. Okay, so all we're going to do is take this, and we're going up, shift goes up 6. We didn't change anything with our slope, so it's still 1. Okay. Okay, here's... Alright, this one says graph the function, and we're changing on the inside. Alright, so when it's on the inside of the bars, opposite world again, it's dealing with horizontal. So this is plus or minus, so we had bring this out to the opposite, so it'd be plus 4. So we had a horizontal shift 4 units to the right. So it starts off here, and all we did was shift it 4 units to the right. Okay. We just did that one, didn't we? Ooh. Sorry guys, I can't read that. Trying to make it out. Write an equation represents the given transformation of the graph g of x equals. See, he's got horizontal translation 9 units to the right, or is that 5? And then a vertical stretch by a factor of 5, and a reflection. Well, if you had a vertical stretch that's on the outside and it's reflecting, then it would be this. So this is vertical stretch. The 5's on the outside. It's also a negative, so that means that it's a reflection on the x-axis. Okay. All right, let's look at this one. It says compare the graphs, find the value of h. Well, they've got plus h here. So it went 2 units to the left, so that would be negative 2. So in opposite world, it would be positive 2. Okay, so it'd be x plus 2. Okay, I think that's it. Yep, that's it. All right, so maybe that'll help you a little bit in reviewing for your Chapter 3 test. All right, okay. See y'all later.